that the company has received and the benefits that it has given everyone who's listened to audio over the years.
Thank you, Jimmy. This particular development, which you will see in the U.S. patent, was actually issued in July of 1949 and was the result of the research work that we did back in 47 and 48. The purpose behind the development of this particular type of transformer was the necessity of eliminating the quasi-switching transient in Class B and Class AB 1 and 2 amplifier modes of operation. What happens there is that a current is alternately taken first by one half of the amplifier or one side of it, and then by the other half. Two tubes are actually used to synthesize the entire sine wave. But the real synthesis is actually carried on by the transformer. In this particular case, if it were a standard push-pull circuit, the reversal of winding direction as a result of current entering the center of the winding would be the effective instrument for reconstituting the continuous sine wave. The reversal of direction, of course, of the direct current that is supplied by the power supply via the both sides of the output amplifier is the goal. Now, normally, you would have to make one half of the transformer somewhat displaced physically from the other half to reduce the capacitive coupling from one side of the circuit to the other in order to have some reasonable high-frequency performance. In this particular case, the capacity between the windings would shunt current from the windings through the capacitance, and as a result, it would never see the load. So when you go to measure the high-frequency performance of such a circuit, you will find in the center of the sine wave a little notch, a switching transient. This develops when one tube stops drawing current and the magnetic lines of flux suddenly collapse around that winding. And because that winding isn't completely 100% coupled to the other winding, that transient or exponential decay of the flux generates a corresponding current, which, while it isn't coupled to the other side of the amplifier, can be coupled into the secondary and so appear at the output of the amplifier. There hasn't really been any way of getting rid of this particular phenomenon because of the necessity of limiting the total number of turns in the transformer at the low frequency end so that you aren't shunted by the open circuit inductance of the transformer. So you have to use enough turns to meet the 20 cycle performance requirement. When you do that, then there are too many turns that are not coupled to each other for the high frequency performance of a standard push-pull transformer. While I was meditating on this problem one really hot, steamy night in Washington, D.C., about July of 1947, it suddenly occurred to me that if we could use half a transformer and use it in the anode circuit of one tube and the cathode circuit of another tube, then we could accomplish the current reversal via the two tubes and have one common winding where there wouldn't be any coupling problem at all. I set up a circuit to demonstrate the feasibility of this to Mr. McIntosh, and while it was demonstrable that we could eliminate the switching transient, the problem of actually driving such a circuit and supplying the DC power to it was really pretty sizable. Mr. McIntosh was a really indefatigable thinker. He slept very little at night, sat up all night dreaming up ways of getting around this, and one of the methods he proposed was winding the two wires of a transformer side by side and then putting them in a circuit such as this so that when current flows in this wire and the magnetic field surrounds it, having the other winding right alongside it meant that you could have almost 100% coupling of those two magnetic fields. After exploring very many different circuit arrangements such as this particular one, we then arrived at a symmetrical type of circuit where half of the output transformer was in the cathode circuit of one tube and the plate circuit of the opposite tube. And then, of course, the same was true on the opposite side. This way, we were able to have the two windings coupled both magnetically and capacitively, so that there was less than a fraction of a microhenry of leakage inductance between the two windings, where in a standard transformer you're up in the range of 10 to 12 millihenries of leakage inductance. So you can see two ways of looking at this circuit. One is that you have arranged to wind both windings exactly on top of each other with the two wires parallel to each other, and rearrange the circuit so the capacitance between those two windings, instead of having a deleterious effect on the performance, actually supports the performance of the transformer. And of course, the other way of looking at it is that you have achieved 100% coupling between both halves of the transformer. So now when one tube stops drawing current, the magnetic field is not free to collapse at its own rate. As it moves from a positive or a negative value, it has to drive the other tube or meet the driving current of the other tube. That means that, supposing you were thinking of a mechanical analogy, in a reciprocating engine, if you had a lot of slop in the two pistons connecting the drive shaft, you would have a constant knock, 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 or click, click, click type of thing, and that would be just about analogous to the switching transient electrically. So what we've done is reduce the coupling error to zero, or another way of saying it, produce 100% coupling one side to the other. We coined an expression for this and called the circuit a unity-coupled, balanced differential feed. This way, another advantage picked up, and that was that each tube has about 12 decibels of negative feedback via half of the cathode winding. Since that is a voltage feedback, the effect is to reduce not only the nonlinear distortion of this particular type of output stage, but also to reduce the equivalent generator resistance so that you build up the damping factor or improve the constancy of the output voltage regulation from full load to no load. So this was the main advantage of the McIntosh output circuit, in that with what looks more or less like a standard transformer coming from a coil winder, you actually have a brand new type of circuit. It wasn't possible for anyone to really circumvent these patents. We applied for 5 different divisions, and they were granted over a period of years that allowed us to extend the life of the patent until just about 5 years ago, before the patents actually expired. But by now, the cost of making this type of transformer is really out of sight for any of the mass production competition that we have. We have never been a mass production house. We have always produced a very limited quantity of products, but tried to do an excellent job, an excelling type of job, a job dedicated to performance and reliability. And this is the beginning of this whole McIntosh story. Since this particular time, one type of patent after another has followed this development. Naturally, I have not been responsible for them, but our engineering staff, which is headed by Sidney Quarterman, who's the vice president in charge of research and development, has been really prolific in their inventive approach to solving problems that have meaningful benefits to the customer who is going to use this system in a home entertainment reproduction application where he desires or she desires absolutely perfect sound reproduction in the home.
Hi, I'm Mike. This is AudioClassics.com. We got a real quick look on the new McIntosh MEN 220 room correction system. Just came in, still cold. Just a real fast look here. On this side, we've got the navigate control, power standby, select button, voicing button, menu button, bypass, focus mode, global mode, and then adjust. Okay, this is what it looks like powered up. We'll spin it around, see what the back looks like. Okay, on the back, IEC, power control, data, RS-232 port, microphone input, unbalanced inputs, balanced inputs, high and low outputs, unbalanced, and high and low balanced. Comes with a really cool little remote. Actually, very cool. Microphone, microphone cable. Also comes with tripod, which I haven't even opened yet, but we're going to get to it soon. So there it is, the McIntosh MEN 220. Brand new from McIntosh. I think this is the 5th one they've built. I'm Mike. This is AudioClassics.com.